Okay. Hi, all of you. Good afternoon. Online, offline, all of you. Hi, Bhumi, Hemant, Venkatesh, Jyoti, Abhiroop, Sanjay Shri. Yeah, all of you. Good afternoon. I could see a flurry of doubts yesterday. By the way, for those who have not uh, maybe saved, this is my phone number. My request is, if you have doubts, send in a WhatsApp message. I reply generally, and uh, try asking doubts which I can answer on the WhatsApp. You know, sir, टेक्टोनिक्स कुछ समझ में नहीं आया, समझा दो. उसका मैं क्या करूंगा बताओ. Okay, so some clarifications. Okay, you can always ask me. ठीक है? Yeah, this number stays with me. It's there since I ever bought a phone. Okay, so you can write in. The last evening I had quite a bit of doubts, so I'll revise the topic once again. If you still have queries, I'll take it up, okay, on a personal basis then. Okay, let's start off now. So our discussion had started into plate tectonics, okay, and we mentioned how plate tectonics is an improvement over the concept of continental drift. The idea continents are moving is right, but what's the process? What floats over what? How the mountains are formed? Why we have volcanoes? They are better explained by tectonics theory. Drift theory had some errors. One is Sial floating over Steema was wrong. The Sial scraping while floating is wrong. The idea that continents can move only north and westward is wrong. Continents are pulled by sun and moon. That's also wrong. And it did not tell us about the origin of the Pangea. Okay, ये 5 main points हैं. I'll read out some questions also where they've asked you to compare tectonics and drift theory. Okay, so tectonics theory, I said, is not a single theory. Many concepts have been developed. They all converge into one single idea, and the many theories are, some ideas from drift also was taken. The idea of convection currents, the idea of sea floor spreading. Somebody named, okay, those blocks as, okay, plates. Somebody says these movements are a consequence of the convection cells, while the lithospheric plates float over the asthenosphere. Okay, each 4-5 points are important. So one question asked me was, so what is this paving stone hypothesis? Okay, लिखो मत, बस सुन लो. What do you mean by paving stones? अगर आपने रोड देखा है या टाइल, okay, देखा है फ्लोर पे, okay, so when you arrange the tiles, okay, like this, as a stones आप डाल देते हो, these type of surface is called as paved surface, PAVED. ये टर्म सुना है आपने? Paving the footpath, paving the roads. Paving का मतलब होता है any surface where you put stones on them. So if you look from top, a paved surface looks like this. ये एक टाइल है, ये एक स्टोन है, ये एक और स्टोन है, ये एक और स्टोन है. One more tile is here, a brick maybe. You must have seen how the surface can be, paved by bricks also. Red bricks डाल देते हैं. Okay, so our lithosphere looks like those paved bricks, as in this is one block of, okay, continent or plate, one more block of oceans and plates. So ये जो blocks हैं, they were called as paving stones. Okay, the paving stone idea को हटाकर Wilson called those blocks as plates. That's why the beginnings of the tectonics theory, we just know this name. What is Mackenzie and Parker's paving stone hypothesis? Essentially, plates की बात कर रहे हैं. Until Wilson named those blocks as plates. Okay? That's for one additional information here. Achha, now, in the tectonics theory, we said lithosphere, it floats over the asthenosphere. ये one point है. Second point, lithosphere is blocks. Okay, the blocks called as plates. The third point is the lithospheric plates, they are interacting. They move and collide, they move apart, they rub against one another. These are the three main interactions, okay, of the plates. So we will take up one interaction separately and discuss what are the features associated with each of the plates. Transverse. Transverse का मतलब ये होता है, if this is one block, if this is one block and this block is moving like this and this block moves like this. This is an interaction where the plates are not colliding, not moving away, but rubbing like this. इसी को बोलते हैं slip interactions भी बोलते हैं. It's also called as slip interactions. And if it's a proper boundary, we call that as a transform boundary. Okay, so we'll come back on this afterwards. Okay, yes, Hemant, correct, yes. Okay, so we started one by one. We talked first about the divergent boundaries. We said divergent boundaries में क्या हो रहा है? Diverge means moving apart. Divergent boundaries happen when there is a rising and a diverging limb. Rising and diverging limb, where there are two blocks of lithosphere and this traction pull will move the plate like this and this traction pull moves the plate like this. This rising limb, I said, can be under the continents, they can be under the oceans also. Sea floor spreading theory jo hai, it's the example of a divergent boundary at the oceans. Like if this was a massive continent, this was an ocean, okay, and a divergent limb develops here for whatever reason. Now this divergent limb can break this and this part moves like this part moves like this. This is what was sea floor spreading hypothesis. Okay, and you know the features linked to sea floor spreading. We'll have a more axial rift valley. We'll have the increasing age of oceans. We'll have basaltic eruptions. We can have trenches farther away if there is a subduction boundary. So whatever you have studied under sea floor spreading is essentially the divergent boundary under the oceans. But tectonics says that this divergent boundary can also develop under the continents. So this is a massive thick continent और इसके अंदर भी ऐसा ही divergent boundary बन सकता है. So we have explained what is the sequence through which the divergent boundary develops. Initially, this continent will get uplifted. Why? Because ये pushing up. Remember, continents are, remember lighter याद आ रहा है आपको? Continents are less dense, 2.5. If you have a strong push from underneath, continents बाहर आ जाएंगे. They can swell out. Okay. So there is some deformation here, and because of this deformation, okay, the continents can bulge like this. We call this as the domal upliftment. If the domal upliftment ज़्यादा होगा, तो यहाँ पर there will be some cracks. We call this as continental stretching and continental rifting. If this pull is very, very strong, eventually this whole thing can break, okay, and these two pieces can move apart. And when they move apart, okay, Oops. Now in between, I can have an ocean formation here. The two blocks have now moved apart. Okay? So, continental rifting ultimately will lead to the formation of an ocean. Continents का composition क्या है? Remember, andesite. Continents composition is diorite. Continents are made up of granite. And what type of lava comes out here? I've said this is basalt lava. ये जो नया crust क्या बनेगा? ये basalt बनेगा. And basalt is going to be the ocean floor. Okay? So somebody, one of you asked me again, sir, इसमें पानी कहाँ से आता है ocean का? You don't realize this is the earth, this is the continent. इसके चारों तरफ क्या है? All ocean here. So if there is a crack here and the oceans move apart, when the water enter here? Okay. So when oceans move apart, and this is a top view. ये ऊपर से दिखा रहे हैं आपको. This is a cross section view. Oceans move apart. ये जो पानी चारों तरफ है, ये अंदर आ जाएगा. So we have got now water here. That's how the first oceans are made. Is it okay, all of you here? We call this as the nascent ocean. Yeah, example of domal upliftment is Ethiopian highlands. The Red Sea is a nascent ocean. The Great African Rift Valley is an example of an ocean as a continent rifting. And ultimately, if the process of Arabia splitting apart continues, we'll have a massive ocean between Arabia and Africa. Check all of you done here. So we had one diagram here. Let me show that to you ek baar. Yeah, you all can see this. Okay, so this is the African Rift Valley here. Okay, ये Red Sea hai and this Gulf of Aden. Okay, so once Arabian Peninsula was joined with Africa, so politically we say Arabia is part of Asia. इसका हम बोलते हैं Middle East बोलते हैं या फिर West Asia बोलते हैं. Reality में in terms of rocks, in terms of structure, Arabia and Africa have the same type of rocks. And this Red Sea is the beginnings of a large ocean. The floor of Red Sea is going to be basalt. Okay, and this is another diagram. Okay, I have shown Red Sea here, Rift Valley here, and Gulf of Aden. This is the Gulf of Aden. Okay, so yahin par we have a triple junction. This is where we have the triple junction. Ye wala point. This point here. So rising plume. You can see the rising plume here. Okay, lava rising. It breaks up. So one arm is here. One arm is here. One arm is here. And as of now, this African Rift Valley is the failed arm. अभी यहाँ पर failed arm मतलब है यहाँ पर अभी activity है नहीं. In the future, we anticipate this again can get reactivated. कुछ models होंगे. They have studied on those lines. So as of now, this and this are active. देख रहे हैं आपको ये खुल रहा है ऐसे. And this is all opening up here. Okay. And this Rift Valley, it goes north like this. It goes on this side. इधर चला जाएगा. Anybody knows ये triangle को क्या बोलते हैं? The Sinai Peninsula. The Sinai Peninsula has two water bodies. Okay. On the left hand side, this is the Gulf of Suez. On the east, it is the Gulf of Aqaba. Okay. This is Africa. Africa here. Okay. This is the Sinai Peninsula. The Arabia. Djibouti. So this water body kya hai? This is called as the Gulf of Aqaba. And this is the Gulf of Suez. The Rift Valley है, वो किस तरफ है? वो इधर है. It goes northwards into the Gulf of Aqaba. Then into parts of Israel. We have the Jordan Valley, Rift Valley, along with the Jordan River and the Dead Sea. जॉर्डन रिवर एंड द डेड सी, ये ऐसे जाकर ये ऊपर चली जाती है, ये वाली पार्ट। ठीक है, ऑल ऑफ यू? सो बैक टू योर diagram I was showing you. Okay, so it goes on the eastern side, Gulf of Aqaba. It goes northwards. Yeah, Rift Valley hai. This Rift Valley is occupied by River Jordan. River Jordan, no, Jordan country, Israel, West Bank, and the rest. Can we see African arm activating in our lifetime, Sankalp? It depends आपका lifetime कितने million years का है. Okay, मैं तो शायद रहूंगा नहीं. Okay, but I can't be sure about you, Sankalp. Okay, so 2-3-4 million years wait karo, you might see something there in your lifetime. Anybody else? Yeah. Not necessarily. It's a fault. Transform fault means they are moving. So if Africa here was having this one like this like, tab ye transform fault banega na. Right now the movement is across like this. This is called as normal fault. When they are rubbing like this, we call this transform fault. When there's a slippage going on, there's no slippage here. They are moving apart like this. We call this as normal fault. As of now, the African Rift Valley is a normal fault, not a transform fault. It can be a transform fault. In some cases, hota hai. The triple junctions, in this case is, okay, I have a rift, I have a rift, I have a rift. Sometimes it can be, okay, a rift, a more and a more. Sometimes it can be one more and two rift valleys. There are a lot of combinations possible in the triple junctions. Here we have the rifting systems happening in 3 arms. Hemant, there should be a reason, but I can't explain it. It's beyond my scope and my knowledge. Yes, Shivam, correct. Anybody else here? Huh? क्या दोबारा? In which case, continent or oceans, magma? It requires more force to come out. The eruption on the continents will require more force because continents are harder, oceans are softer. तो सॉफ्ट वाला पार्ट आराम से खुल जाएगा. वाटर प्रेशर उसकी कोई औकात नहीं है यार. कन्वेक्शन करेंट्स की बात कर रहे हैं कि द मूविंग कॉन्टिनेंट्स, पानी क्या कर लेगा उसमें? Okay, that water has, okay, is nothing. It's like me jumping on the floor and asking, can I cause a mental movement or not? Okay, ignore that. What decide divergent motions? Convection cells. ये किधर मूव करेगा, क्यों मूव करेगा? It's all linked to convection cells. Sun और moon का कोई रोल नहीं. All because of mental dynamism, all because of mental interactions. ठीक है? Basalt rocks are softer, correct. Basalt rocks will easily puncture out, so not much force required. In case of continents, continents are harder. The continents will require this cracking, rifting, breaking apart. It requires more forces. Yeah, mores are always under the sea, correct. That's why they call it as mid-ocean, MOR, mid-ocean ridges. They always are under the sea. I'll find all of you here. Okay, any questions? So if I list down, what are the features associated with divergent boundaries? अगर ये आपको कहीं पूछेगा तो आप क्या लिखोगे? Okay, the features depends on the divergent boundaries on the ocean floor है या फिर it is on the continents. On the ocean floor, sea floor spreading, और सारा listing कर देना. More, Rift Valley, basalt eruptions, increasing age of oceans, whatever you know on the sea floor spreading. अगर on the continents है, the domal upliftment, you can have rift valleys, you can have continental thinning and breakage. Okay, and ultimately this will lead to nascent ocean, and this ultimately becomes this. Shweta, well, you will learn as we expand on these concepts. Yes, yes. Divergent boundaries, if it continues, will ultimately lead to ocean flow. You are right. अगर रुक गया बीच में, like African Rift Valley वो अलग बात है. If the divergent boundary continues, it will lead to ocean floor creation. And that is how perhaps the formation of the continents of today happened. That is how perhaps how the Pangaea broke up, how Gondwana land broke up, how Africa separated from South America. Yes, right. I can move on from here now. Triple junctions mein aa raha hai aapko, all of you. So one of you asked me, sir, are there more triple junctions? Absolutely. Let me see if the diagram is here. It was. और कहाँ divergent boundary triple junctions हैं. Now see, on this diagram, okay, जहां पर भी तीन plates हैं, this is a triple junction, this is a triple junction, okay, this we have said is a triple junction, ये African Valley वाला है, this is a triple junction, this is a triple junction, wherever you have got three arms, ये भी triple junction है, okay, wherever the three plates are joining and they have names, okay, if I'm not wrong, this one here is called as, I think, Bouvet, B-O-U-V-E-T triple junction. South America, Africa, and this one. एक यहाँ पर है, जुआन दी फूका के साथ में है, ये वाला, this is called as Mendocino, I think. Mendocino triple junction. वैसे एक पुराना ट्रिपल जंक्शन यहाँ पर है, बट अब एक्टिव नहीं है. यहाँ पर एक फॉल्ट है, called as the Bennu fault, B-E-N-U-E, Bennu fault, which has lot of oil today. There's one triple junction here called as the Bennu triple junction. So there are many triple junctions. Okay, so just know this. Okay, I mean you don't have to know all the details here. Okay, so any three arms joining together. Okay, in this case, ये भी ridge है, ये भी ridge है, ये भी ridge है. It's called a ridge triple junction. In some cases, यहाँ पर transform boundary है. I can have a ridge. Okay, I have a convergence boundary and a transform boundary. So triple junctions are of different types. Okay. So maybe if you write this, just this दो name लिख लो. Other examples of triple junctions. Back to yesterday's notes. उसी में add कर लो. Other examples of triple junctions. And put a question mark. I have to confirm this name. I think I'm right. No, I'm not. I shouldn't be wrong here. Okay. One is B-O-U-V-E-T. B-O-U-V-E-T. This is Southern Atlantic triple junction between South America, Africa, and Antarctic plate. Okay. ये एक triple junction है. वैसे triple junction said Mendocino. M-E-N-D-I-C-I-N-O. Mendocino triple junction. This is, this is one the Fuca plate, North America and Pacific plate. Just know this as Mendocino triple junction. Anugya, tell me, what is your question? No, you have got it wrong, Anugya. Okay. Within the lithosphere, the crust and the upper mantle are fused together. But I never said lithosphere is fused to asthenosphere. ये तो आपने assume कर लिया. The lithosphere has two parts. The lithosphere is asking me, सर अगर lithosphere is fused to asthenosphere, ये movement कैसे है? ये गलत हो गया. The lithosphere is not fused to the asthenosphere. Within the lithosphere, the crust and the upper part of upper mantle, they are fused. The lithosphere and asthenosphere to loose hai. That's how the lithosphere floats over the asthenosphere. Anugya. Absolutely, Kaushik. ये सब geography GS वाले topics हैं. Okay, we are teaching in optional a bit more detail, but you have been asked questions on this in GS also. So know this. Can I move on now? Revise the topic of yesterday. Okay, let's move on now. Now we'll discuss, okay, the convergent boundaries. Convergent boundaries. I suggested this to all of you once. Please make your summary sheets of diagrams also. और ये हर दिन का काम नहीं है. Sit down for 3-4 days, class कर लो. On the 4th day, 5th day, make a summary of all diagrams I've taught in the 4 classes. Okay. Again, sit once in 3-4 days. Again, make a summary. So at tomorrow, try making summaries of all diagrams I've taught till now in geomorphology. Start from interiors of Earth. Okay, some diagrams on the P and the S waves, some diagrams of drift theory, diagrams of tectonics. So whatever diagrams you have made till now, put them in one sheet. मेरे notes का PDF कैसे use करें? अभिरूप, that's only for, okay, a reference. Okay, that's a bad habit we have started. Okay, but वो reference के लिए कायदे से the notes of the class is enough. If you missed out some point, अगर कोई word छूट गया, कोई diagram छूट गया, go and look up your notes that I'm giving you. Okay, and for those who are missing the classes, okay, I hope they study from that. Okay, I'm moving on now. Convergent boundaries. So, divergent boundaries कैसे बनते हैं? Rising and diverging limbs. Convergent boundaries are converging and descending limbs. So, surface of Earth here, rising limb, descending limb, rising limb, descending limb, rising limb, descending limb, rising, this is diverging, this is rising, diverging. So, इस part में they are converging and they are going down, and that's how, okay, this cell completes. That's how the cell completes. So, at this location, we have divergent boundaries. At this location, we will have convergent boundaries. So, point number 1. Convergent boundaries are at the location of converging and descending convection cells of the mantle. Convergent boundaries develop at the locations of converging and descending limbs of the mantle convection cells. Convection cells. Yeah. The convergent boundaries are at the location of converging and descending, sinking, descending, okay, convection cells of the mantle. ठीक है? Limbs of the mantle होना चाहिए था, but ठीक है, कोई बात नहीं, understand that now. Next, there are three types of convergent boundaries. Depending on the three types of convergent boundaries, depending on the type of lithosphere, that are interacting. Depending on the type of lithosphere that are interacting. जैसे हमने कहा था divergent boundary में, there are two types of divergent boundaries. One where the oceans are spreading and one where the continents are spreading. Okay. In case of divergent boundaries, दो type हैं. In case of convergent boundaries, there are three types. So when convergence happens, It's possible that, okay, it's a continent here, this is an ocean, this is an ocean, convergence, okay, both colliding. This is an example of ocean-ocean collision. I can have a continent, I can have an ocean, another continent, and say I have convergence here. This example of ocean continent conversion collisions. Ocean ये है, ये continent है. And sometimes there are two continents. They are colliding. I have continent collisions. The three type of collisions: ocean-ocean collision, ocean-continent collision, and continent-continent collision. Okay, the three types of collisions: OO collision, OC collision, and CC collision. So one of you asked me in previous batch, किसी ने पूछा था मुझे, so in case of divergent boundary, why can't we have ocean-continent divergence? Essentially, this is a continent, okay, a large continent. This is the ocean. Okay, so I can have a divergent boundary here. I can have a divergent boundary here. Why can't I have a divergent boundary here? जिसके एक तरफ continent है, एक तरफ ocean है. Answer is, this is a zone where fusion has happened. Okay, for ocean continent, the limb must be exactly at this. Can you understand how precise it must be here? हल्का सा अगर इधर आ जाएगा तो क्या हो जाएगा? CC हो जाएगा. Continent is breaking. हल्का सा उधर जाएगा, it'll become OO. It'll become ocean is spreading out. So continent ocean ऐसा होता नहीं है. Any case, अगर यहाँ टूटता भी है, ultimately what's coming out? Basalt coming out. This ultimately will become this or this. It can't be exactly continent one side and ocean one side. Exactly ऐसा नहीं होता, because when lava comes out, you're bound to have basalt here, no? Basalt का मतलब है it has now become an ocean spreading zone. So for divergent boundaries, we always have two types, either under the oceans or under the continents. But in case of collision boundaries, I can have all the three. I can have O collisions, I can have OC collisions, and I can have CC collisions. Okay, let's start off with OO collisions. Give us a heading. OO collisions. No Abhirup. Don't assume that. Okay. Let me teach this. फिर ये क्वेश्चन आपका और क्लियर हो जाएगा. ठीक है. O collisions. Now सुन लो पहले. Continent is here. There is one ocean slab. There is another ocean slab here, and there is convergence and sinking limbs here. When collision happens, there are only two possibilities. Both of them either go down together. So ऐसे भी गया और ऐसे भी गया. Okay, this doesn't happen. For this to happen, both the arms must be exactly same force. ऐसा कभी होता नहीं. Generally, when you pull down, either this gets pulled down or this gets pulled down. Okay, and that depends on इन दोनों में कौन सा strong है. Both can't be exactly same type of strength. One of them will be stronger, or in these two, which is the heavier one? You can imagine this, right? Continent, ये छोटा सा ocean part है, और ये वाला बड़ा सा ocean part है. This is ocean A, ocean B. Which one will be heavier? B is heavier. So B is heavier. Okay. B will slightly sag like this. It sags like this. When you have got convergence going on, this slab will get this slab will get pulled inside. So both the slabs don't get pulled in at the same time. Always one of them will get pulled in. That's one point. Now, when they get pulled in, remember this is hot magma, hot mantle. When it gets pulled in, एक तो यहाँ पर gap बन जाएगा. This gap is called as the trench. Any collision boundaries where ocean is subducting, I will have a gap called as trench. Achha. On the ocean floor, there will be a lot of sediments here. There will be small mountains and plateaus here. When going down, okay, there will be scraping again going on. This scraping, the sediments are इकट्ठा होके, all of it will get plastered on the other side. Example I think I gave you, if I apply foam on my face for shaving, okay, and I run the razor. So razor में क्या होगा? The foam gets attached. Okay, so think of that kind. I put some sediments here. Okay, and when it's subducting down, the stable one, this will scrape. While scraping, the sediments of this will get plastered on this edge. So sediments of the ocean slab B get plastered on the slab A. I call the sediments as we call this as accretionary prism. What are the features linked to O collision? One is trench formation. The second is accretionary prism formation. फिर क्या है? This slab going down, it's very hot here. Very hot, some of it will melt here. And this molten lava will rise up, break this one, and form volcanic accumulations here. Okay, these are volcanic accumulations. They become islands, they become continuous island chains, okay, along the side of the trench. ये trench होगा, इसके side में ही I'll have a long linear chain of accumulations of volcanoes. एक चीज याद रहे that this volcanic accumulations ये basalt नहीं होगा. This will be andesite. Now look, when I have divergent boundary, what lava comes out here? Basalt. ये कौन सा rock है? ये mantle rock है. Mantle rock is what rock? You remember a name I gave you? It will be peridotite. So chemical reactions में the peridotite converts into basalts. यहाँ पर क्या होगा? The slab going down. ये किस type का rock है? ये basalt है. When basalt melts, basalt will now convert into. Okay. यहाँ पर the mantle rocks got converted. यहाँ पर क्या होगा? Basalt will get converted. Okay. And what I will get is andesitic type of volcanic accumulations. So more accumulations are not same as accumulations at the locations near the trenches. ये andesitic accumulations होंगे. I'll talk about the property a bit more there. These are the main 5 things happening. One, I said ocean will subduct. Number 2, trench is forming. Number 3, there's the accretionary prism. Number 4, there's melting of the subducting slab. And number 5, I will have andesitic volcanic accumulations on the other slab. Yes, andesite is one type of igneous rocks. Yes, you're right. Trenches are present, hollow space, while lava can't come out. बेटा मेल्ट यहां हो रहा है ना. When something light is rising, वो कैसे राइज? वो ऐसे राइज करेगा, कैसे टेढ़ा होकर राइज करेगा? निधि, how will it rise? In this scale, this is couple of 1,000 kilometers. When lava rises, lava will rise straight. She's asking me, sir, lava trench से क्यों नहीं निकलेगा? Because trench टेढ़ा है. Okay, lava will not turn like this and go like this. Lava will go straight up puncture. So they are near the trench, but not at the trench. At the trench, there is no volcanic eruption. At the trench, you only have rubbing actions going on. You'll have earthquakes happening. You'll have scraping going on. But I will not have volcanoes here. But trench ke paas mein, on the other slab, I will have volcanic accumulations. नहीं, इज इट ओके? रोल ऑफ वाटर, वाटर की कोई औकात नहीं है वाटर की। वाटर अंदर यहां तक जाएगा, गर्म होकर बाहर आ जाएगा, स्टीम होकर निकल जाएगा। वाटर विल नॉट एंटर एंड ओके इम्पैक्ट हियर, द वाटर ऑलवेज रिमेन्स ऑन द टॉप। ओके, इट मीन्स देयर इज ट्रेंच। यस, अगर ट्रेंच है एंड द ट्रेंच एक्टिव है, वो इंपॉर्टेंट है। अगर एक्टिव ट्रेंच है, आई विल हैव वोल्केनिक इरप्शंस। व्हाट इज पेरिडोटाइट? God teaches patience like this. Okay, one is when you become a father. पापा वो क्या है? कौवा। घूम के आएगा, पापा वो क्या है? बेटा वही कौवा है। दिखा के आएगा, पापा वो क्या है? ना कौवा है। वो काला वाला क्या है? वो फिर भी कौवा है। Okay, so बेटा ये भी कौवा है। Okay, I told this कौवा couple of days ago. This is one type of a rock. It is an igneous rock, the main rock of the mantle. कौवा याद हुआ? What is peridotite? Okay, good, nice. अब कौवा याद रखना. Anybody asks me, you know what कौवा questions? कौवा questions. Okay, come back. So, write few lines first, then I'll help you draw the diagram again. Because बहुत hot है. It's very, very hot. Basalt melting point is lower than melting point of the mantle. Okay, it's so hot. अंदर जाते ये, और ये ऐसा नहीं कि सारा मेल्ट हो रहा है. Okay, कुछ रह भी जाएगा, कुछ मेल्ट करके ऊपर आएगा और कुछ मेल्ट होकर मैंटल में मिल जाएगा, एंड यही वाला फिर आके इधर आ जाएगा. Okay, उसमें फिर और ट्रांसफॉर्मेशंस होंगे. यहां पर सम अमाउंट ऑफ लावा विल राइज अप हियर. ठीक है? ओके, राइट डाउन. ओ कोलिजन्स में पॉइंट वाइज. ओके, नंबर one of the ocean slab will be pulled into the mantle. One of the ocean slab will be pulled into the mantle. Within bracket, depends on the strength of the convection limb and the weight of the ocean slab. Depends on the strength of the convection limb and the weight of the ocean slab. So, of the two, whichever is heavier will go inside first. Within bracket mention, oceans are denser than continents. Oceans are denser than continents. So, ocean floors will get pulled into the mantle. Ocean floors will get pulled into the mantle. ये dense है. Okay, 3.5 is the density of oceans. When the convection cell is going inside, this dense one can be pulled into the mantle. Number 2, next point. This process is called as subduction. This process is called as subduction. Subduction. Third point, at subduction boundaries, there will be, number 1, a trench. At subduction boundaries, there will be, number 1, trench. Trench क्या है? Trench is not a valley. Trench is a gap between the two slabs. Okay, so trench is not a regular valley. There will be a trench which is not a regular river valley जैसे है, वैसे गड्ढा नहीं है. It's a gap. It's a gap between two slabs. There will be a trench, number 1. Number 2, there will be accretionary prism. There will be accretionary, ACCRETIONARY, accretionary prism because of because of sediments scraped from the subducting ocean lithosphere. Sediments scraped from the subducting ocean lithosphere. ठीक है, तो ये जो सेडिमेंट्स हैं, ये किस टाइप के रॉक्स होंगे? विल दे बी बसाल्ट और एंडेसाइट और ग्रेनाइट? क्या बोलोगे आप? व्हाट विल दे बी? या दे सोर्स फ्रॉम व्हाट? फ्रॉम ओशन फ्लोर. So what type of sediments will this be? Okay. Rule 1, ये sediments है. Sediments को आप क्लासिफाई नहीं करते हो as basalt or granite or diorite. You just call them as sediments. That's all. Okay. Sediments are not same as rocks. Okay. Sediments, they can form sedimentary rocks. वो अलग चीज है फिर. So there is, it's like, you know, okay, I have a wood slab. Okay, when I grind it, तो वो थोड़ी wood slab रहेगा, वो फिर sawdust बन जाता है, right? Sawdust is not same as wood, is it? I have iron rod, उसका आपने filing कर दिया. I can have iron dust. I will not have iron rod anymore, right? So don't make a mistake of calling this as basalt. ये बस sediments है. Sediments includes many things. वो rock के fragments होंगे, वो deep ocean के life form remains होंगे. It'll include some amount of weathering of rocks also. It's a mixture of sediments. So don't classify the sediments as basalt or any other type of rocks. Okay? So we'll have accretionary prism, okay, on the other side of the slab. Okay. Next. वो सब क्रश हो गया, वो सब भी हम sediments ही बोलेंगे. Whatever mountains you might have had, okay, it's all crushed now. जैसे दीवार था, आपने तोड़ दिया, तोड़ के क्या मिला आपको? आपको डस्ट मिला. अभी थोड़ी बोलो कि दीवार मिला आपको. Okay, so whatever you must have had here, mountains हैं, plateaus हैं, all of them get crushed, deformed, they are scraped and plastered as sediments. The word accretion का मतलब होता है इकट्ठा हो गया. Accretion means growth. Sediments have combined together and they have formed some kind of accumulations. They no longer are rocks of the oceans anymore. Okay? These are two features. One is trench, second is the accretionary prism. The next point. The subducting ocean slab can melt while descending, and can form andesitic volcanic accumulations. These accumulations can rise up and expose above the waters. They can rise up and expose above the waters as islands. Okay? So it's like, okay, this is the continent. The continent hai, this is the ocean slab, and this is the water. Okay. So lava coming out here punctures this, okay, and it accumulates here, और जब बाहर आ गया, so this part now becomes an island. And remember, I am drawing a cross section. Reality में, okay, this is, you know, imagine this here. ये पूरा एक slab है. This is the continent here. Whole thing is slab. So I have volcanoes. I'll have volcanoes along this entire line. volcanoes here, volcanoes here, volcanoes here. एक line बनेगा. Okay. This is called as the island chains, or also called as island arcs. Head down. उसी point में. The volcanic accumulations are continuous chains. The island accumulations are continuous chains. Chains called as island arcs, called as island arcs, or archipelagos. They're called as archipelagos, archipelagos. They're called as archipelagos. Like, yes, like Andaman Nicobar Islands, like Japanese islands, Philippines islands, Andaman Nicobar Islands, Japanese islands, Philippines islands, Indonesian islands, Northern Pacific में we have a group called as Aleutian Islands, ALEUTIN. ये अलास्का का पार्ट है. अभी रिसेंटली काफी न्यूज में है called as Kuril Islands, called as the Kuril, Kurile, Kuril Islands. अभी इसी साल 2-3 बार along Kuril Islands, okay, we have had lot of volcanic eruptions with tsunami alerts. ये एरिया है called as Kamchatka Peninsula. Kamchatka Peninsula. Okay, Kuril Islands. So ये न्यूज में रहते हैं. Okay, these areas, इंडोनेशिया में eruption हुआ, वो भी न्यूज में रहा. Japanese tsunami alert रहा. Okay, big one happened again. Okay, so all of these are locations. Andaman में भी eruptions हुआ, if you remember. In fact, we discovered some oil also along Andaman coast in recent times. Yes, Barren Island has again erupted. Correct. Yes. Okay. So if I draw the map here of the Pacific Ocean, so this is Siberia, Kamchatka Peninsula. Okay, that's Korea. This is Alaska. Yeah, we have these islands here. This is North America. Gulf of Tonkin. That's Vietnam. I hope आप पहचान पा रहे हो हम क्या ड्रॉ कर रहे हैं. These islands, Honshu, Shikoku, Kyushu here. We have got small islands here of Philippines here. Come down like this. We have islands of Indonesia here, and that is the equator. Spend some time on the maps of the world. South America. Okay, so this is the Pacific Ocean. The Pacific Ocean is going like this. This is the ocean part of Eurasia. Okay, like this, and the Pacific one is going underneath. Okay, so diagram में, okay, पहले क्या है? पहले आपका यहाँ पर ट्रेंच होगा और यहाँ पर पहले ट्रेंच होगा, then prism है, then you will have andesitic eruptions. Okay, the Pacific part, this is the Eurasian plate, Eurasia continent, and the sea part, ocean part of Eurasia. So they are colliding. When they're colliding, the Pacific one goes underneath. I'll have a trench, and then I will have iron arcs. हम वही बना रहे हैं यहाँ पर. The Pacific goes underneath. I will have deep trenches here. यहाँ एक trench है, यहाँ trench है, यहाँ trench है, ये trench है. Okay. And islands, the acacia prism यहाँ दिखता नहीं है because water के नीचे है. Okay. These are the islands, and these are Okhotsk Sea, Sea of Japan, East China Sea, South China Sea, and so on. Okay. So draw this diagram. These islands are called as Aleutian Islands. These islands are called as Kuril Islands. These are Japan Islands. This is Philippines Island. These are the islands of Indonesia. ये Java है. This is Sumatra here. This is island of Borneo here. So please make the diagram. प्रिज्म आपको दिख नहीं रहा है, अंडर वाटर है, और आइलैंड बन रहा है, वो क्यों समझ में नहीं आ रहा है? द वोल्केनिक इरप्शन हैपनिंग, द लावा इज पाइलिंग अप, बढ़ते बढ़ते पानी के बाहर आ जाएगा तो आइलैंड दिखाई देगा. मैंटल इज डेंसर देन ओशन क्रस्ट. यस, बिकॉज द कन्वेक्शन सेल्स आर पुलिंग इट इनटू द मैंटल. दैट्स व्हाई. चैतन्य, convection cells are strong, वो खींच रहे हैं and they're pulling it inside the mantle. That's why the ocean slab enters into the mantle. I'll show you the maps also, पर आपने ड्राइंग कर लो आप. Yes, कैरिबियन, हाँ इस डायग्राम में नहीं होगा, बट यस वो भी ऐसे ही कुछ है. करेक्ट. We have the Caribbean islands here. Mexico here. So we have Cuba, Puerto Rico. You have got US Virgin Islands, British Virgin Islands. यहाँ पर जमाइका, केमन आइलैंड्स हैं. Okay. And this, if you remember, was the Caribbean plate, ये वाला. So here we are saying the Pacific plate is subducting under the Eurasian plate. Sri Lanka is continental, not because of this. Diagram बन गया, all of you? Okay. These are Japanese islands. The northern one is called as Hokkaido Island. This big one is called as Honshu Islands. और भी small islands हैं. These are the islands of Philippines. Yes, आदित्य. हाँ, यहां पर एक और ट्रेंच है. ये फिलीपींस ट्रेंच है, यहां पर एक और ट्रेंच है. दिस इज कॉल्ड एज मरियाना ट्रेंच. तो ये अलग प्लेट है. ओके, वी हैव अ फिलीपींस प्लेट एंड वी हैव द पैसिफिक प्लेट. विल कम बैक ऑन दैट. वेट, दिस पार्ट इज डन, ऑल ऑफ यू? ऑल डन? Okay, write down. Write down. OO collision is a feature of a Western Pacific and Northern Pacific. Is a feature of Western Pacific and Northern Pacific. ये है वेस्टर्न पैसिफिक और ये है नदर्न पैसिफिक. नदर्न पैसिफिक में ये भी एक ट्रेंच बनेगा. या ड्रॉ नहीं किया मैंने, ये ट्रेंच है। तो क्यूरिल आइलैंड्स, क्यूरिल ट्रेंच, जापान आइलैंड्स, जापान ट्रेंच, Aleutian Islands, Aleutian Trench. Okay, so Pacific Ocean is subducting under the other plates of the world. All done here? Let me see if I have a diagram on this. I do have. It's all mixed up now. Okay, this one. Here, watch. Okay, so we have, this is ocean, ये ocean है, ये continent. Okay, this is one plate. One plate, the continent part and the ocean part. This is the only ocean part here. The ocean is going down. Okay, goes down. This is the trench. This is the trench here, and not showing here, but along this you'll have the sediments accumulating. This is melting, going up and forming chains of islands here. These chains are called as archipelagos. So this line is called as the arc line बोलते हैं इसको, arc line. इस arc line में the towards the trench इसको बोलते हैं fore arc. This part here is called as the fore arc, मतलब before, and this part is called as the back arc. This is the fore arc. All done? The trenches are on the fore arc side. The accretion prism is on the fore arc side. Back arc में क्या रहेगा? Back arc will become marginal seas. ये भी sea है. The Sea of Japan, Okhotsk Sea. You have the South China Sea. You have the East China Sea. We call these as the back arc basins or back arc seas. So back to your notes and write on 2 lines here. The island arcs separate the fore arc region. The island arc separate the fore arc region from the back arcs. The fore arcs from the back arc. The fore arc has the trench and the accretionary prism. They are the trenches and the accretionary prism. And the back arc is a basin with marginal seas. The back arc is a basin with marginal मतलब क्या? Margins में, ocean के margins में, with marginal seas. Example of back arc basin seas are, examples of back arc basin seas are 1, 2, 3, 4. 1, Sea of Japan. Sea of Japan. Number 2, East China Sea, South China Sea, East China Sea, South China Sea in the Western Pacific. In the Western Pacific. And Bering Sea in Northern Pacific. And Bering Sea in the northern Pacific. Okay. So these are the seas here. This is Sea of Japan. This is the East China Sea. इधर आते आते South China Sea, and this is called as the Bering Sea. Bering Sea is between Aleutian Islands and the north, called as the Bering Sea. They can't be perfect straight lines. Can the islands be exactly straight like this? No, because edge of a continent या ocean कभी perfect straight नहीं होगा ना, हल्का से ऐसे ऐसे होगा, ऐसे होगा तो आइलैंड्स भी ऐसे ही होंगे, ऐसे होंगे, ऐसे होंगे, ऐसे होंगे, इसीलिए इसको आर्क बोल देते हैं. बेरिंग, BERING, बेरिंग सी, और उसके बियॉन्ड इज बेरिंग स्ट्रेट, बेरिंग सी एंड बेरिंग स्ट्रेट. ठीक है. सो इट्स नॉट कैप्चर्ड हियर. चलो आपको हम एटलस में दिखा देंगे. किसी के पास एटलस है? एनीबडी हैज एन एटलस? एनी एटलस विल डू. थैंक यू. वन ऑफ ठीक. Thank you. So I'm looking at Orient Black Swan Atlas. I'll open up the map of Asia. Look at all of you. Okay, so watch here. So this is the Kamchatka Peninsula here. Okay, these are the Kuril Islands here. I think दिख रहा है आपको सबको? Clear? So this is the Kuril Islands. यहाँ पे लिखा है Kuril Trench. If I turn here, Aleutian Trench. यहाँ पर Aleutian Islands हैं, and this is the Bering Sea. ठीक है? This is the Sea of Okhotsk. Sea of Okhotsk. On Ichiao, you'll have Sea of Japan. यहाँ पर Sea of Japan है. Okay, these are the islands. Hokkaido Island. We have the Honshu Island here. Okay, you come down, you have East China Sea. You come further down, you have got South China Sea. South China Sea, these are the islands of Philippines. Okay, along Philippines, you have Philippines Trench. ये Philippines Trench है. ये Philippines Trench. Philippines Islands. ये South China Sea. This is the equator here. Equator है, बोर्नियो से कटता है. Okay. And these are also the islands of Indonesia. Sumatra, Java, Lombok, Sunda Islands, Celebes Islands. So all of these are island arcs. Okay. So all these regions are areas of O collision. यहाँ पर ocean part here, ocean part here, colliding. यहाँ पर south से Indo-Austral plate, north से the Pacific plate. This part is called the Burma plate. They are colliding here. Sorry, yeah, here. So this part here is a collision arc here. Take all of you. If you show on the complete world map, doesn't show. ठीक है, इसमें देख लेते हैं. We'll see this part here. Okay, so this is Kamchatka Peninsula, Okhotsk here. The Japanese islands are here. You come down. These are the Philippines islands here. Okay, this is South China Sea, East China Sea. This is Sea of Japan here. We'll have Japanese trench. We'll have Philippines trench. Here you'll have Kurils trench. Okay. और इधर देखेंगे तो you'll have Aleutian trench somewhere here. Is it okay? This is the part of the Western Pacific. और वैसे यहाँ पर भी trenches हैं. You have got one trench here called as the Sunda Java trench. Okay. So this is the boundary of the Indian plate and the Pacific or the Burma plate. Okay. This is the Philippines plate here. So they interact here. This creates the islands of Indonesia, and you'll have Indonesian trenches called as Sunda Java trench. इसका नाम है Sunda trench. SUNDA. All of these are very active zones. They're full of volcanoes here. Okay? Yeah, back to your notes now. Anugya, I'm ignoring your questions right now. You are going beyond what I'm teaching, so the बाद में देखेंगे. Is this okay, all of you? So what are the features? Listing कर लो. The features associated with O collision. Just 1 to 2 listing कर लो. Trench, accretionary prism, trench, accretionary prism, archipelagos, fore-arc region, and back-arc region. Fore-arc region and back-arc region. All done? 4, 5, 6 features, okay, of the OO collision boundary. तो मरियाना ट्रेंच का कहानी क्या है? तो ये एक अलग प्लेट है. दिस इज अ सेपरेट प्लेट. तो यहां पर फिलीपींस प्लेट कोलाइडिंग विथ पैसिफिक प्लेट, एंड दिस इज द यूरेशियन पार्ट कोलाइडिंग विथ द फिलीपींस प्लेट. तो इन दिस पार्ट, ये वाला पार्ट जो है, इट इज लाइक अ कॉन्टिनेंट. यहां पर कॉन्टिनेंट हियर, वी हैव द यूरेशियन पार्ट हियर. Okay, we have the Philippines plate going down like this, and we have the Pacific plate going down like this. So this is the Mariana Trench, and this is the Philippines Trench. And yahan se volcanisms, I will have islands here called as the Philippines Island. isse bhi islands hain, but these are not very important ones. So ignore karo. What you see is the Philippines Island alongside Philippines Trench, और थोड़ा दूर में we have the Mariana Trench. This is a small minor plate. This is the Philippines plate. Philippines plate subducting under the Eurasian plate. बना लो इसको, big deal. So give a heading, Philippines and Mariana Trench. Philippines and Mariana Trench. तो यहाँ पर okay, 3 plate. This is the ocean, one interaction. ये भी ocean, another interaction. All good? Then we come to next one. Ocean continent collisions. OC collisions. In case of OC, now you'll have one ocean slab subducting, and one side you have the continent. This is the converging and sinking mantle limbs. तो इसमें क्या क्या फीचर्स होगा? Okay, so you definitely will have a trench, gap तो रहेगा. The sediments of the ocean floor will now get plastered on the edge of the continents, and these can be very huge amount. They can rise up and these can become fold mountains. ये पूरा ऐसे sedimentary accumulations होगा, they become fold mountains. In case of O collision, the sediments are generally not much. Okay? In case of OC, now you have got lot of sediments here. So O collisions में the mountains don't come out. Okay, वहां पर होता sediments, but they don't form mountains like the way we see mountains. In the OC ones, sediments can come out. Okay, so this is the water surface here, and this is the fold mountain like the Andes. And the subducting plate can again melt, lava comes out, and the lava can accumulate here, and these can become the volcanic peaks on the mountains. These are the volcanic peaks on the mountains. I'll draw this using a black color. So I will not have an island arc here. Why? Because ये वाला continent part है. There's no ocean back arc zone नहीं है. So unlike O collisions, which have a back arc zone, यहाँ पर there's no back arc zone. Directly continents. So I'll have a trench. I'll have accretionary prism that becomes fold mountains. The melting of the subducting slab. Okay, this melting can create volcanic eruptions that become volcanic accumulations on the fold mountains. Right now? Okay. So, क्या features are? Number one is a trench. Number one is a trench. Number two will be the accretionary prism that forms fold mountains. The accretionary prism. It forms fold mountains along the edge of the continents. Along the edge of the continents. Like the Andes Mountains of South America. Like the Andes Mountains of South America. Like Rockies Mountains of North America. Like Rockies Mountains of North America. Atlas Mountains of Northwest Africa. Atlas Mountains ये सब कॉन्टिनेंट के एज में होंगे. Atlas Mountains of Northwest Africa. The third, there will be andesitic eruptions, andesitic volcanic eruptions because of subducting slab andesitic volcanic eruptions because of subducting slab, and the eruptions will be on the fold mountains. The eruptions will be on the fold mountains. Like, write 4-5 names like Mount Chimborazo, Mount Cotopaxi, Mount Ojas del Salados, Mount Aconcagua. These mountains are on Andes mountains. ये सारे volcanic peaks हैं. We'll have Mount Whitney. We have Mount McKinley. It's also called as Mount Denali. ये अलास्का में. This is in California. But we also have Mount St. Helens. Is also in US, northwestern US, a range called as Cascade Ranges. So these mountains are part of Rockies Mountains. ये जो mountains हैं, they are part of Rockies Mountains. Mount Chimborazo, Mount Cotopaxi, Mount Ojas del Salados, Mount Aconcagua. Some consider Mount Ojas del Salados is the highest active volcanic peak. Okay. Some books say Cotopaxi hai. So ठीक है, you can remember both. Okay. Mount Aconcagua is no longer active, but this is the highest peak of Andes. Okay. Aconcagua, लिख लो within brackets. Mount Aconcagua is the highest peak of Andes mountains, but not an active volcano. Okay, but this is the active, highest active peak है, Ojas del Salados. And what type of eruptions will this be? All of them are andesitic because they are conversion of the ocean basalt into eruptions. So all of them will have what type of rocks? Andesite rocks. ये सब lava basalt नहीं है. The lava is andesite type of lava. Okay. If I show this to you on that list, so this is your South America. That's South America. So this is the Pacific part colliding with the South American one here, and this mountain along the edge. This is the Andes Mountains. Okay. वैसे अगर आप North America देखोगे here, okay, this is North American mountains called as the Rockies Mountains here. ये पूरा system continuous system. So starting from Alaska, Rockies, comes down towards California. यहाँ पर Mexico है. It comes down further down south, a continuous range into South America as the Andes Mountains. Everywhere it is the Pacific Ocean colliding with the South America. The Pacific Ocean colliding with North America. But remember, when I say Pacific Ocean, I don't mean Pacific plate. Actually, यहाँ पर what plate do we have? We have Nazca plate. आपको ये diagram याद है, I believe. You remember the diagram of the plates. So look at this diagram, all of you. Okay. So this is the Pacific plate, ये वाला. ये Pacific plate है. And this is plate called as Nazca plate. This is Nazca plate. यहाँ पर एक plate है called as Cocos plate. So the collision यहाँ पर is Nazca plate of the Pacific Ocean colliding with South American plate. This is OC boundary. This is the Cocos plate of Pacific Ocean, with again the American plate and the Caribbean part. This is the Pacific plate and the Pacific Ocean दोनों है colliding with the American continent. ठीक है? वैसे यहाँ पर this is the a part of the collisions. Now it's not active anymore, but यहाँ पर कभी active हुआ करता था. We have the Atlas Mountains here. So the main active zone of this collision is the Andes Mountains along South America here and the Rockies Mountains along North America. Okay? So back to your notes, write down. The Andes Mountains are mainly because of the Nazca ocean plate, the Nazca, Nazca, Nazca ocean plate subducting under the South American continent, Number 2, the Rockies Mountains are because of the Pacific plate subducting under the North American plate. Okay? So know the exact names of which plate colliding with which plate. Nazca plate colliding with South America, and this is largely the Pacific plate colliding with North America. So if I want to show you those mountain ranges, back in your room, make sure that you have seen the atlases एक बार. It helps you remember, recall, revise. Here. So South American continent में you can see Cotopaxi. This country here is Ecuador. This is Colombia. Ecuador, Colombia. This is Peru. This is Venezuela. Okay. So Cotopaxi is here. Chimborazo. Both are part of Ecuador. Country Ecuador है. यहाँ पे देखो. This is the country called Ecuador. Okay. इस country के साथ में you have the physical map. Cotopaxi and Chimborazo. You come down south, you can see Aconcagua here. Aconcagua is boundary of Chile and Argentina. Is a Chile country, Argentina country. This is Aconcagua. और north में देखोगे again Chile and Argentina के boundary में भी have Ojos del Salados. देख रहे हैं Ojos Salados here. In Atlas, if you look up, you can see these mountains. Okay, so this whole thing is the Andes Mountains, and in North America, if you see, this is Mount Whitney, California का part यहाँ पर है. Mount Whitney is here, and if you look further northwards, you can see Mount. यहाँ पे लिखा है Rainier Mountains. These Rainier Mountains will have St. Helens. यहीं पर होगा St. Helens, and Denali is shown in Alaska. This is Denali Mountains. Denali Mountain here. तो पुराना नाम उसने लिखा भी है McKinley. McKinley was the older name. Is it visible to all of you? No. You must have Atlas for this. You can. Up, I think it's better. Yeah, this is Denali Mountains in Alaska. Also, old name was McKinley Mountains. Okay, so there are many such ranges and mountains you can look up one by one. Yeah, Cascade Range is also part of the Rocky system. जैसे Shivaliks is part of Himalayas, Pir Panjal is part of Himalayas. वैसे ही Cascade Range, Coast Range, Pacific Coast, okay, Brooks Range, Alaskan Range. They are the names within the Rockies mountain. ठीक है? I believe all good here. Forgotten where it was. Yes. I'll come to that. Give me a few minutes on that. Why the OC collisions have more sediments for mountains? I'll come back on this in a few minutes के बाद. Yes, yes, Anugya. Ocean continents are collision which create lot of sediments that become fold mountains. Fatima, क्या question है? These fold mountains are geologically oceanic origin. Yes, all fold mountains. All fold mountains have ocean origins. They all will have sediments of marine origin. Yes, Fatima, correct. Yes, they are not upliftment of continental rocks. They are upliftment of marine sediments. Okay, because of collisions. Correct. Abhiroop, I use a mix. I recommend you can have 3 atlases with you. One is Oxford Atlas. It's very neat for some of the entries. You can use TTK Atlas and you can use Orient Black Swan. अगर दो ही खरीदना है, you can buy Oxford Atlas and you can buy Orient Black Swan. These two are enough. Okay, let's move on. Next is, so I'm done with the OC collisions. अब इसमें एक point add कर दो. Just add one point here, add on. OC collisions are also associated with granitic lavas. They also are associated with granitic lava that remain inside the continents. Forming the core of the fold mountains. Within bracket mention, granitic lava or granitic rocks are intrusive rocks. Granitic rocks are intrusive rocks. They form intrusive landforms. Like batholiths, batholith. They form intrusive landforms like batholith, batholiths. Let me explain this to you. Now see, OC बड़ा आसान है. Sorry, O, no problem. Continent, ocean, subduction happening. This is melting, rising up, falling, forming the andesite island arc. Okay, but in OC collision, there are some complexities. Ocean goes down. This is the continent here. Okay, a trench formation. You have this massive accretionary prism that forms fold mountains. Okay, और जो लावा निकल रहा है, lava is two types. One lava goes up and forms the volcanic peaks here. This is one type of lava coming out. Plus, you also have one more type of lava coming out that doesn't go out. It forms massive rocks inside the continent itself. So, in case of O collisions, I have only andesite eruptions. In case of OC collisions, okay, so OC collisions mein, there are two types of lava or two types of magma bol lo. One magma is andesite. This andesite, they form volcanic mountains on the fold mountains, and you also have granitic magma. This granitic magma, they form intrusive landforms. ये बाहर नहीं आएंगे. They remain inside the continents. Can you all draw this diagram? Lot of Y part I am skipping for now. To explain this, I must enter into volcanism process. Okay. So I'll come back, explain that when I'm discussing volcanism. अभी आप इतना लिख के जाओ. In the OC collision boundaries, there are two types of magma. One is andesite magma that becomes the mountain peaks on the fold mountains. ये volcanic mountains बनते हैं. Plus, you also have granitic magma. You also have granitic magma. ये कभी बाहर नहीं आएगा. Granite is an intrusive rock. ये अंदर ही रहेगा हमेशा. And these intrusive, okay, rocks, they form intrusive landforms. We call those as, okay, batholiths, phacoliths, laccoliths, if you know some names. Yeah. The red one is coming out. Red is andesite. The black is granite. This is granite. This is a granite. It forms intrusive landforms. One example of which is batholith. Batholith is one type of intrusive landform. ये सिर्फ OC में बनेगा. You do not have this in OO type of collisions. अनुज्ञा, आप आगे कूद के क्यों चले जा रहे हो? इतना लिखो ना आप. वेदरिंग है नहीं है वो बाद में देखा जाएगा. Yellow, this is accretionary prism. This is accretionary prism. ठीक है? This forms fold mountains. Fold mountains of the Andes type of mountains. All done here? The third type of collisions are the CC collisions. The CC collisions. You can do that the way we made a list of features for OC collisions, O collisions. You can also make a list of features for OC collisions. Trench, fold mountains, volcanic peaks, and you can add batholiths. The 5 features of the OC collisions. एक समरी बना लो, आपने रिवीजन के लिए काम आएगा. OC collisions will have trench, will have fold mountains, will have volcanic peaks. Okay, trenches, fold mountains, volcanic peaks, and batholith formations. OC mein there are no island arcs. OC will not have back arc basins. All done? Okay. Now, in CC collisions, so we have 2 continents colliding. इसमें ocean नहीं है. And we have converging and sinking limbs. Okay. CC collisions. The crushing, there will be sediments in between. Okay. And the sediments, they form enormous fold mountains, okay, away from the coast. Okay. So for CC collisions, the sediments fuse, they get squashed and they rise up as enormous fold mountains but are away from the coast. Okay. Examples of these type of mountains are Himalayas. Himalayas coast में नहीं है. Himalaya mountains, Hindu Kush mountains, away from the coast. The Ural mountains, away from the coast. We have Kunlunshan mountains of China. Kunlun, Kunlunshan mountains of China. Okay? 4-5 names. Enormous fold mountains away from the coast. And within bracket mention that these sediments are also of ocean origin. They're also of ocean origin. But the ocean slabs are now destroyed. Ocean slabs are now destroyed. Okay. Now see, continents are lighter, हल्के होते हैं. Continents are buoyant. So no matter how strongly the currents pull inside, continents will not go inside. They keep on getting crushed. They keep on getting squashed. They keep on getting compressed here. Continents will not subduct. Only oceans can subduct. देखो, at CC collisions, there are no subductions. At CC collisions, there are no subductions. There are no subductions. There will be continuous continental compression. There will be continuous continental compressions and mountain upliftments. So this this convection limb, when they come and squash here, the continents will keep on getting compressed and compressed. Or sediments jo hoga, because you're compressing more and more, sediments will keep on rising. So these mountains will become very high mountains. Okay. Add a point here. Because there are no subducting ocean floors or ocean lithosphere. Because there are no subducting ocean lithosphere, there will be no active volcanism. There will be no active volcanism. The Himalayas mein, we don't have active volcanism. Okay. You only have crushing, earthquakes hoga, you'll have lot of faults, but you'll have no volcanic eruptions. But there will be active seismic zones. They are seismic as in earthquake zones. There's no volcanic eruptions, but there are active earthquake zones like the Himalayas. आप सुनते रहते हैं, right? Every frequently now and then, Afghanistan has earthquakes. Okay, Himalayas has had earthquakes. Earthquakes we do here in parts of, okay, you know, your Turkish regions also. It's all because, okay, collisions goes on, but there is no volcanism here. Achha, now, yeah. तो ये दोनों अगर डेंस होते भी हैं, वो डेंस आपस में होंगे, बट दे स्टिल आर वेरी लाइट. ओके, वो भारी हल्का इन दोनों में होगा ना कंपैरिजन. भारी हल्का इज नॉट विथ योर मेंटल, राइट? सो दे विल कीप ऑन कोलाइडिंग. वन ऑफ देम कैन गेट अंडर थ्रस्ट, वो अलग बात है, बट दे विल नॉट एंटर द मेंटल. इज जैसे इफ अ ट्रक एंड ए कार कोलाइड, okay, when they collide, they will not enter the earth's crust. Collide करके ऊपर फेंका जाएंगे. Okay, when two bodies are colliding on the land, they don't enter the mantle. When they collide, they can get thrown upwards. So continents are so light that no matter what you do, they will not subduct into the mantle. ठीक है all of you here? अच्छा, now सुन लो पहले इसको. ये जो कोलिजन है, ओसी कोलिजन, ओ कोलिजन, ओसी एंड सीसी, एक्चुअली these are, okay, a part of a continuous sequence. Imagine this. I have continent, I have ocean, I have continent, I have ocean. This is ocean collision, continent C1, ocean O1, ocean O2, continent C2. Okay, collision is going on. होगा क्या ultimately? Okay, this will come closer. ये पास आ जाएगा. Okay, so I have C1 here, I have O1 here. अब O2 जो है वो छोटा हो गया and C2 has come here. Goes on colliding. I have C1 here, I have O1 here. The O2 has completely gone down and now I have C2. Okay, this is the collision part. ये collision part. यहां पर अब ये collision हो रहा है. O2 has gone. O2 has gone. Now I still have the convection cells. तो यहां जब collision होगा, ocean is heavier, much heavier than continents. So now the ocean will go down. Okay, so I'll have C1. I have O1 now going down. And I have C2. So it started with ocean. It now has become ocean continent. This continues for some more time. Okay, C1 is here, ocean O1 going down, and I have got C2 here. Ultimately, ocean has completely gone. अब क्या बचा आपके पास में? C1 and C2. This is now becomes CC. So the three types of collision boundaries you have are actually three stages in the collision process. समझ में आ रहा है यहां पर? Look at the ocean going on. I will have a accretionary prism forming here. The prism is the sediments of O2. Okay. अब सारा sediments यहां इकट्ठा हो गया. Now when the scraping happens, this sediments will get plastered on the continent side. Okay. Sediments हैं. Collision goes on. Plastered here. Oceans have gone. अब क्या बचेगा आपका? Sediments between the two continents. So the sediments you have, they are slowly accumulating. So now listen. This is say stage 1, stage 2, stage 3, stage 4, stage 5 and stage 6. सबसे कम sediments कहां पर होगा? 1. Sediments at 1 and 2 are these more or sediments at 4 is more? 4 is more. Why? Because 4 has the sediment of the entire ocean floor. समझ में आ रहा है यहां पर? That is why this sediment is lost sediments and they become mountains. ये पूछा ना आपने क्वेश्चन मुझे, why does this become mountain and not this one? Because ये sediments कम है. Imagine entire Pacific Ocean subducts. जितना इकट्ठा होगा वो huge amount sediments होगा. And now they will start accumulating on C2. 5 वाला ज्यादा है कि 6 वाला ज्यादा है? 6 is maximum. So when the collision becomes CC type, the sediments are the maximum sediments. All of them are ocean origin. यहां पर ocean है नहीं, but ये sediments कहां से आ रहा है आपका? Ocean से आ रहा है, right? That is how the fold mountains, whether oceans हो ना हो, they will be of the oceanic origin. Is it okay, all of you here? So give a subheading. Okay. The sequence in the development of the collision boundaries. The sequence in the development of collision boundaries. The first point. Yes, Hemant. Hemant says, continents be like, मैं झुकेगा नहीं. Okay. मैं झुकेगा नहीं, मैं बर्बाद होके, क्रश होके, okay, माउंटेन बनेगा, लेकिन सबडक्शन नहीं होगा. ठीक है? Okay, fine. Write down. The three types of collision boundaries are actually three sequence in. They actually are three sequence in the development of collision boundaries. The three types of collision boundaries are actually sequence in the development of collision boundaries. Next point. The process starts with OO collisions. The process starts with OO collisions with the least amount of accretionary prism. The process starts with collision boundaries with the least amount of accretionary prism. Within bracket, not enough to rise up above water as mountain ranges. Not enough to rise up above water as mountain ranges. Number 2. The OC collision is the next stage. The OC collision is the next stage. When one of the ocean slabs have completely subducted. Where one of the ocean slabs have completely subducted. Is सब समझ में आ रहा, all of you here? Okay. So this is when two ocean floors are there. One ocean floor sinking, the prism forming, the O2 is gone. अब आपका O1 रह गया. Now when the O1 starts subducting, sediments get plastered on the C2. तो ये जो prism होगा, this prism, okay, let me take a one by one. This sediments is what? The sediments of the ocean O2 alone. जब यहां पर आएगा, ये क्या होगा बताओ? The sediments of O2 gone plus sediments of O1 now sinking. समझ में आ रहा है? And remember, when O collision था, do you recall? We also had a island arc here. याद आ रहा है? We also had island arc here. ये island arc भी क्रश होने वाला है. Okay, so ये जो collision sedimentary rocks यहां पर है, this has what? This has the sediments of O2 plus sediments of O1 plus the crushed rocks of the island arcs. याद आ रहा है? When that gets crushed, remember? Plus, which is harder, continents or oceans? Oceans. Which is harder? Continents are harder. Right? ये हमने शुरू से बताया था आपको, continents are harder, they are brittle, oceans are softer, oceans are basalt. याद आ रहा है? So when collision happens, which will break? The hard will break or soft will break? The hard will break. Soft deform हो जाएगा. Soft will bend. The hard ones will break. So when ये collision चल रहा होगा, the rocks of continent C2 is also breaking. So imagine this prism has what all things? This has sediments of O2. It has sediments of O1. It has crushed rocks of the island arcs plus some crushed rocks of the continent edge also. So ये जो prism है, can you imagine it's a huge amount of sediments now? And this prism is far more complex than this prism. Is it okay? Back to your notes. The accretionary prism at OC collisions. The accretionary, next point. The accretionary prism at OC collisions are more complex. Are more complex and enormous. They are more complex and enormous because they have the sediments of both ocean floors. They have sediments of both ocean floors, comma, crushed rocks of island arcs, crushed rocks of island arcs, and crushed continental rocks also. And crushed continental rocks also. ठीक है? So this is more complex and more enormous amount. That is why they become fold mountains. They rise up as very large accumulations. And by the time they come here, they have all of this together crushed here. इसी में ऐड करो, same point add down. The OC collisions therefore have more sediments. They have more sediments with more diverse composition. There are more sediments with more diverse composition and are forced as fold mountains. And are forced as fold mountains along the edge of continents. Along the edge of the continents. Okay? The next one. At CC collisions, the amount of sediments are maximum. Because they are remnants of, the amount of sediments are the maximum because they are remnants of all the above collision boundaries. The remnants of all the above collision boundaries, but without the subducting ocean floor. But without the subducting ocean floor. Hence, the CC collision fold mountains are the highest mountains. Hence, the CC collision fold mountains are the highest fold mountains. I hope I explained a couple of dimensions here. Right? So, why this becomes fold mountains and not this? And why these collisions are the highest fold mountains that we have? Achha, now see. When basic physics nahi bolenge, but more of common sense, okay? Say I am pushing some material, compressing. While pushing, there are two possibilities. One possibility is, while pushing, there's something going inside. And a second possibility, while pushing, nothing going inside. In which case, will the force be more stronger? When something goes inside, the force are stronger, or when not going inside, the force are stronger. Anybody? When you have got two forces like this, और एक केस ऐसा है, इस फोर्स का एक कंपोनेंट नीचे भी जा रहा है, और एक केस है, the force are face to face and nothing goes inside. Say this is force A, this is force B. Okay, because of resolution, this force will be less than A because एक कंपोनेंट नीचे जा चुका है. So when this collides, this force is less than this force. यहाँ तो entire force is completely face to face. Is it okay all of you? In physics we call this as there is no resolution of force here. The entire force is perpendicular thrust. पूरा face to face. Okay, दोनों force है. When you have a stone and you want to push it, which case will the stone go more? When you push the stone straight like this, or when you push the stone like this one, case A or case B? In which case will the stone move more? Case A. Why? Because B case में एक force नीचे push कर रहा होगा और एक यहाँ जा रहा होगा. So this is less than this perpendicular force. Is it okay all of you? So in CC collisions, there is no subduction component anymore. So CC collisions will have the maximum compressive force. So look at this. The CC collision has the maximum sediments. Number two, the CC collision also has the maximum force. Will the mountains be higher? So CC collision mountains are the highest fold mountains that we have, like we have in case of Himalayas. That correct point? The CC collisions, the CC collision boundaries, next point, are associated with the strongest compressive force. They're associated with the strongest compressive forces within bracket because there is no subduction component. Because there is no subduction component. This further explains why the fold mountains of CC type, why the fold mountains of the CC type are the highest fold mountains, are the highest fold mountains. Is it okay? Achha. Now one more thing, because in the CC collisions, the forces are the strongest. That is why the folds also become a bit more complex. What's a fold? Imagine you have a bed sheet here. और bedsheet को आप ऐसे fold कर रहे हो. You're pushing like this. So won't the bedsheet form, okay, some folds like this? Okay. So fold mountains यही होते हैं. I have got a layer of sedimentary rocks. ये sedimentary layers हैं. And you are compressing the sedimentary layers. The sedimentary layers are of marine origin. When you compress it, these sedimentary layers will form folds like this. The sedimentary layers have formed folds like this, and we call these as fold mountains. Now these folds can be, okay, simple symmetrical folds. मतलब ये angle जितना है, ये angle उतना ही. We call this as simple symmetrical folds. So this is an example of a simple symmetrical fold. Okay, but अगर compression बहुत ज़्यादा होगा, they become very steep. Okay, they can become very steep like this. These are the folds. If you keep on compressing, can you imagine? Mountain इतना बढ़ जाएगा कि अब ये गिरना शुरू हो जाएगा. Okay, so the fold mountain now can't stay straight. It'll start bending like this. If you keep on compressing more, okay, these can bend even more like this, and they ultimately will fall on the ground like this. Can you all imagine? Okay, so these are not simple folds, they are complex folds. It's like, again same thing, try this on a bed sheet. So keep on folding, okay, the fold ultimately गिर जाएगा. Okay, so CC collisions create all these complexities. Write down. In the CC collisions, the fold systems become very complex. The fold systems become very complex because of strong compressive forces. Because of strong compressive forces. The folds can become steep. The folds can become steep, comma, asymmetrical. They can become steep. They can become asymmetrical, comma, overturned folds, and recumbent folds. The गिर गया नीचे is called as recumbent folds. This is called as an overturned fold. These are very steep. The steep ones are called as hogback. The folds can become very steep. We call those as hogback folds. They can bend. We call these as overturned. Overturned का मतलब है they have become now asymmetrical. And when they fall down, we call these as recumbent folds. They fall, they become recumbent folds. You can draw this diagram maybe. This is a simple, open, a symmetrical fold. It is simple, open, symmetrical fold. converts into steep folds called as hogback. They can become overturned asymmetrical or they can become recumbent folds. Recumbent का मतलब है sleeping, गिर के they are sleeping on the ground. Recumbent folds. These features we see in the Himalayas. We'll take out Himalayas separately. I'll discuss that again. If I show this in a diagram, a bit more maybe. So this is say one layer, second layer, third layer, fourth layer. So I color this. Say this is the yellow color. This says blue. And say this is green. When they are bending, when they bend one layer, second layer, third layer, fourth layer, this is one layer of rocks, another layer of rocks, and a third layer of rocks. When they fall on the ground, this, maybe this. I'm coloring this, okay? So you have a sense of ये दिखता कैसे है. Second layer here. And third layer is maybe here like this. Fine, all of you? Layers बन रहे हैं आपके? Now see, if the compression goes on further, it's also possible कि यहाँ से टूट जाएगा. When it breaks, see what happens. When it breaks, this layer remains like this. Comes here, ऐसे टूट गया. Another layer here. This is a third layer here. And okay. Watch. This is the topmost layer. And this is the topmost layer which has relatively टूट के आगे निकल गया. This was the second layer. टूट कर अब यहां आ गया. This is the third layer. And this has now come here. Can you imagine this, all of you? ये diagram imagine कर पा रहे हो आप लोग, all of you? Okay, the fold has now broken. This broken fold is called as nappy structures. When the compressive forces are very, very strong, the folds can break. The relative slippage of the rock layers, the sedimentary rocks. If you can draw, you draw, otherwise, okay. लिख देना ब्रैकेट में, refer to the class board. Okay. Now you see, no, the advantage of using colors. How fast you move. कलर नहीं होगा ना, आप इसको आप क्रॉस करोगे, इसको छक्की मारोगे, इसको गोल गोल करोगे, ठीक है, 3 के बाद में उसके बाद याद भी नहीं आएगा क्या होगा, फिर आप उसको डैश डैश कर दोगे. यूज कलर पेंसिल्स. कलर पेंसिल ब्लंट वाले 2-3 कलर्स, येलो, okay, you can use blue, you can use maybe green, okay, or orange maybe, brown maybe, okay, you will move faster. This part here, you bring it back like this. It's like fold here, fold is bending, the fold breaks and slips like this. So this part, okay, was here, it has now slipped like this because you keep on compressing. So maybe I could have drawn this one ahead, okay, that would help, okay, if that was your point, okay. I can do that too. ऐसे वाला, this one, yes, ठीक. This moves here, this moves ahead. Yeah, color pencil use करो. I will not advise you to use red and green. Red and green I use for corrections. And color pen से better होता है blunt color pencil. Color pen can blot also. Then you have a problem. Color pencil but blunt ones. Sharp में paper फट जाएगा. Blunt ones, rounded nib, rounded tip, you can color very fast. Okay, some of you are using, fine. Yeah, highlighters use कर सकते हो, fluorescent yellow, fluorescent orange, and blue. You are on. But make sure वो blot ना करे. सरकारी पेपर मिलेगा, you never know. Okay, so add कर लो this one in your notes. The complex features are, I said, asymmetrical folds, hogback structures, recumbent folds, and nappy structures. N-A-P-P-E. We call these as nappy. N-A-P-P-E. Nappy structures. फातिमा बेटा जो क्वालिफाई करता है ना, सब ड्रामेबाजी करता है. ओके, कैन वी यूज कलर पेंसिल, टाइम होगा या नहीं, जब जान पे आएगी ना सब कर लोगे आप. नहीं होगा तो लिखोगे नहीं लिखना, जाओ. People who qualify are very different from most people you see. They can juggle all of this together. And underlining, handwriting, schematics, diagram. They can use flow charts because they practice and they increase their speed. ये पहली बार करोगे नहीं बनने वाला. That's what I'm saying. Make your summary sheets of diagrams also. No, Preetha. All of this happening because of convection current. There is no role of gravitation force here. Don't bring in gravitation idea here. All done? So what are the features of the collision boundaries and how are they different from the other type of collision boundaries? All done? Okay, that's for today. Every Thursday, I and Dev Sir at 5:30 have live sessions on the YouTube for essay writing. ज़्यादा नहीं, 45 minutes, 1 घंटे का होता है. Watch those videos and you learn something out of essay writing also then. Okay, so Thursdays 5:30, you can as a rule join in. Generally both of us are there or one of us will be there. That's a time when you can put on your earphones and listen to some bit of talk. Okay. Bye-bye all of you. Yeah, see you tomorrow. Continue tomorrow. Acha, tomorrow, please bring your textbook also. I'll help you mark some pages on Shabbir Sir Geomorphology. Ah, yes, yes. Thank you.